In this video, I'm going to show you how to factor what is called the difference of two squares. And so you might see this abbreviated in your notes like this, difference of two perfect squares. So if you see that, that's what that stands for. So you're going to have a perfect square minus a perfect square. Now, I have used this flowchart to help us in class just kind of organize our thoughts. And our first factoring technique will always be factor out what the greatest common factor would be first. And then after that, what you want to do is look for the number of terms. And since this says two squares, this would be when you have two terms in your polynomial. And so what it's going to look like is this: a square minus a square. And let me use a pen just to make that a little bit brighter for you. And this is how this is going to factor. It's going to factor with your square roots. And one of your factors will have an addition sign, and one of your factors will have a minus sign. And the order of which you write those does not matter, just as long as your two signs are opposite signs. Now I want to show you why this works first with a review of multiplication of your binomials, and then we'll actually do some examples of the difference of two perfect squares. And so when we did in our chapter 8 part 1, and now we're in part 2, which is factoring, I would give you two binomials that looked like this. They look almost identical except for that they are opposite signs. So if we multiply these, what we're going to get is, if I distribute x times x is x squared, x times negative 5 is negative 5x, positive 5 times x is positive 5x, and positive 5 times negative 5 is negative 25. And if we combine our two like terms in the middle that have the same letter with the same power, you'll see that these are going to cancel out. And what we're going to get is x squared minus 25. And so this is what I was talking about before when you have a perfect square, which is x squared, minus another perfect square. How you factor it is your square root. So x times x makes x squared. So notice how that was first in your binomial because that was your first square. And the square root of 25, or a 5 times a 5, is the second number in your binomial because that's the second term of your polynomial. And one factor has a plus and one factor has a minus. So I'm going to show you again that you're going to get a square minus a square for each of these four. So this is kind of what we did in chapter 8 part 1. And then we'll do the section here where we start with this and then we'll try to come up with our two factors, kind of work backwards. So again, if I distribute, 2x times 2x is 4x squared. 2x times positive 1 is a positive 2x. Negative 1 times negative 1 times 2x is negative 2x. And negative 1 times 1 is negative 1. And again, you'll see that these two terms cancel out. And I'm left with a perfect square, which is a 2x times a 2x, minus sign, and another perfect square. So I'll show you two more examples real quick. 2x times 2x is 4x squared. 2x times 6 is negative 12x. Positive 6 times 2x is positive 12x. And positive 6 times negative 6 is negative 36. Again, these cancel out. And I'm left with a perfect square, which is 4x squared, because that was 2x times 2x, a subtract sign, and another perfect square, 36. So again, you'll see our binomials do work out exactly like what we thought. And then x times x is x squared. X times y, negative y, is negative xy. Y times x is also a positive xy. I like to put my variables in alphabetic order, but the order technically doesn't matter. And then y times y is a y squared. So again, when you see those middle terms cancel out, you'll have a perfect square minus a perfect square, and your factors are the square roots, and one has a plus and one has a minus. And so as I'm looking at the questions that we'll have here in chapter 8 part 2, where you are factoring and finding those two factors, notice how I have perfect squares, and in the middle we have that minus sign. And so there are two perfect squares, there's a minus sign in between them. So what we're going to do is find the square of both terms. So the square root of x squared is x times x, and square root of 25 is a 5 times 5. We're going to write the factors as one with a sum and one with a minus. So an x with a 5, an x with a 5, one factor gets a plus sign, one factor gets the minus sign, and the order of your plus and minus does not matter. So again, 4x squared is going to be 2x times 2x. 9 is a 3 times a 3. So my factors get one of each of those. One gets a plus, one gets a minus. And we just did this one here, so hopefully you should see there's a connection here. X times x makes x squared. Y times y makes a y squared. Put them together here. X first because x is first, y second because y is second. One of your factors gets a plus sign, one gets a minus sign. So I will give you a couple more examples here on the next page. So I have about 6 more here for you. And we'll just have slightly more complicated squares. So 9x squared would be a 3x times a 3x. 25 would be a 5 times 5. So each factor gets one of those square roots. One gets a plus sign, one gets a minus sign. And again, the order of which you do your plus and minus sign does not matter. So you could have done minus and then plus. Now for 64x squared, that's an 8x times an 8x. 121, the square root is 11 times 11. So they each get, your factors, they each get an 8x and an 11. One gets a plus and one gets a minus. Again, the order of that doesn't matter. So I have about 4 left here for us. 36x squared would be a 6x times a 6x. And for 1, 1 times 1. And then for this one, notice how, do you see it? There's something wrong with this one. Do you see that there's a sum or a plus sign here? I hope you see it. The sum does not factor. They call this prime. And I'll show you why. I'm going to give you the reason why. If you were to write out a 7x plus a 4 times a 7x plus a 4, when you multiply, you'd get 49x squared plus 28x plus another 28x plus 16. And these two middle terms do not cancel out. And notice how what we have is not a middle, what would that be, 56x is not in the middle here. So this does not work for what we had for our polynomial. Or even if I made them both negative, that would be 49x squared minus 28x minus 28x and plus 16. Notice how I don't have a negative 56x in the middle. That doesn't work. And for me to use a plus and a minus like we had done here, you will get a subtract sign in the middle because a positive times a negative makes a subtract. And so the sum, this is one that I think throws many students off. The sum, when there's a plus sign, does not factor. So that's super important to know. All right, now let's continue on with our difference, meaning subtracting of squares. Here we'd have 7a times 7a. And notice this one we have a number and a letter for the last term, 10 times b and 10 times b. So here's 7a with a 10b, 7a with a 10b. Again, one of your factors gets a plus sign, one gets a minus sign. And then for my last one, I notice that I don't have a perfect square right away because 5 is not a perfect square, but I do notice that I have a GCF. And so what we want to do is factor out that GCF first. Both of these are divisible by 5, and with my letters, I see that I have x squared and x to the 4th. The smaller of the power is a 5x squared. So I'm going to factor that out from both of our terms. If I do that, if I take the 5 out, I have no 5 left. If I had x to the 4th and I take 2 out, I'm left with x squared. And then my subtract sign is in the middle. 5 divided by 5 is 1. X squared divided by x squared is 1. So I have x squared minus 1. And this is going to keep factoring because this will be an x times an x and a 1 times a 1, or an x with a 1, another x with a 1. One factor gets a plus, one factor gets a minus. Just don't forget to also include that GCF in the answer as well. And that is our video for the difference of two perfect squares. I'm not going to answer these three. I'm going to have you try them on your own as kind of practice. But if you want to know the answers, go ahead, look on my Canvas page.